Here it comes. All right, cool. I'll start these.
I already did that.
Did we get a?
No.
All right, we need a Jabber scribe.
Wow.
Jabber scribe, please. All right, thank you, Yoav. Note takers. Any note takers in the audience? I'm sure you're there. Don't be shy.
Trying to make eye contact with someone.
All right, we have a gentleman back there to take notes. Thank you very much. Can you see?
Testing, testing, testing. So when you're at the microphone and you're presenting, you got to eat it a little bit, just FYI. They looked at you. They were like, they need to put it in their mouth to hear anything.
Yeah.
We have an update on this game quarters. And at the end, I'm going to ask this question to you. I'm going to turn to you guys.
Yes, absolutely. I don't know, man. Are we there yet? Are we on Pop Smurf?
We're ready.
We're ready. Let's do it.
Okay.
So this microphone is hot. So
Yeah,
you're
it's
gonna
very-
speak close. Hi.
Yeah, we'll let you.
All right. Hey, I've had the most coffee, so let's see how this goes. Hey, welcome to IETF 104. This is the first TLS session. Is that better, M-Not? Is better? Okay, cool. Hey, welcome. Could we get somebody to grab the doors at the back? Hey, Olaf. Anybody? Hey, thanks. Thanks, Patrick. Next slide. No, well, hey. Is that up there? Okay. Hey, we're on slide 2. This is the note well. It's early in the week. Basically, the plan is participating in the IETF. You agree that to follow the IETF process and policies. We're recording the session. Anything you say at the microphone can be held and used against you. If you have IPR, you need to disclose it if you talk about it at the microphone, the whole 9 yards. There's a bunch of links on there. If you have any problems with anything, you can go to the OBUDS team to discuss that. And again, I said like all the links are there. Next. Requests. Hey, minute taker, we got one. Thank you very much, sir. We got Jabber Scribe. Please, the blue sheets are going around. Please sign them. That'd be great. Please make sure to state your name at the microphone when you get to the microphone to talk. Let's keep it professional at the mic and let's be succinct. We have a lot of presentations and we want to make sure we keep people on time. So let's just kind of try to stick to our meeting time as much as possible. Next, the agenda. We have 2 sessions. So here's today. The demarcation obviously is administrative, which is what we're doing now. And then we have some chair stuff that we want to talk about and a working group draft and then a bunch of non-working group drafts at the end. And then we have another session on Wednesday, I believe, right? Which is the next click. Tomorrow. Sorry, Tuesday. And it's a lot of stuff. Everybody gets, time is going to be very short there, so I hope people can keep their points succinct. Next. Working group status. Hey, we did a lot of working group last called documents. A lot of them are with Ben, who's going to, I believe, going to continue to be our area director. And I'm sure that they're piling up in his inbox and they're burning a hole in his email. So eventually we'll get to those. We're going to be soon to be working group last calling some drafts because they're very close to being done. And we have a couple in progress and we've just adopted some recently. Next. Do you want to talk about this, Chris?
So following in the footsteps of the HB working group, kind of set a good example for having a single location for all the working group information and pointers to relevant documentation and whatnot. We created a new website. As you can see, there are some bits of documentation that could be filled out should you have the time and effort, and the best way to do that is probably just file a pull request on the GitHub repository for the website. So Ideally, we would have a single place where we kind of describe what TLS is and DTLS is for those who are new to the area. We have pointers to the active documents that the working group is working on currently. And sort of an experiment, we'd like to sort of try to see if we can collate a bibliography of sorts of the relevant research and the academic research on the attacks and formal analysis of TLS, similar to the Freehaven Tor bibliography for papers in anonymity, and host it here such that the academics coming to the area could have a single point of reference for getting up to speed with research that's been happening outside of like reading PhD theses and dissertations. We also have pointers to a pointer to an implementation page. Currently, it's just what we had for the 1.3 implementation that Martin spun up. So we hope to fill that out with more information about more TLS stacks and the features they provide going forward. So of course, if you feel so compelled to submit a PR with information about your particular stack, that would be greatly appreciated. And then we will try to keep all this as up to date as possible. And if you have any, feedback or suggestions for what we could add, change, remove, of course, we'd be welcome to hear them. And we hope that going forward, this can kind of help, like I said, sort of consolidate, focus on one particular page for newcomers and existing contributors to the working group. So that said, I think we should just, sorry. Oh yeah, that would be useful, wouldn't it? That's tlswg.org. Thank you, Wes. So with that, I think we should probably just jump right into the presentation. So Russ, you're up first.
Good morning. How close do you have to get to the slide? All right.
You want to switch the mics?
So, but I still have to stand in the pink box.
You do.
All right. So, I'm going to talk about the TLS-103 Cert with External Psk Draft. Just as a reminder, this document proposes an extension which adds the ability to merge the external PSK with the EC, DH, or DH secret in the key schedule. So the idea is that the signature continues to be the basis of the authentication, but we can add a external PSK to the key schedule. The handshake only has these very simple changes. Basically, a flag is included that says you want to do this, and then you use the existing capabilities that are already in the handshake to select the PSK. Basically, an empty value is sent. Just the presence of it is all you need. You need one bit, want to mix it in or you don't. And so that's the very simple syntax that's provided. It basically invokes some rules that say you have to include those other otherwise optional elements in the handshake in order to select the PSK that's going to be used. So what really happens in the key schedule is this is the normal key schedule. The PSK is only present for resumption in TLS-103. The idea is you put this in the same spot, the external PSK, when this is selected. Last meeting, I was asked what proof has been done, whether this provides any additional security or adds any fragility. And so I'm offering some informal reasoning about that at this point. The first is that the authentication is still based on the signature, so there's no change there. Second is the key schedule. Without this extension, in the initial handshake, you're actually computing an extract of 00. So that is essentially a constant. Here, we're going to replace that with an extract of the selected external PSK at 0. So I would argue that adding any entropy here can only help. It's certainly not breaking anything. So the next steps, we've been talking about this for over a year. Along the way, we kind of took a bunch of side routes because we looked at adding some things, and then after some further discussion, we took those back out. And so we're essentially back to the place that was the original 00, the original individual 00. And so I think that having now completed that loop, that it's ready for working group last call, but I'd certainly like to have people review it. And then when the chairs are comfortable that we've had enough discussion, last call it. Any questions? Cool.
What we got?
Jonathan Hoyland, Cloudflare. Not to bang the drum of formal analysis, but it is a little bit more complicated than just saying, oh yeah, it looks fine. I think getting a formal analysis wouldn't be particularly harder than what's already been done, just extending the work that's been done. But it might be an idea to actually find someone to do it.
Okay. Do you have a pointer that you have in mind, or?
Not particularly, but I've heard there's lots of academics out there.
Mm-hmm. Yeah. Go ahead.
Watson Ladd, also from Cloudflare. I just have a question about, is this going to enable the sending of early data if you have this mode or not?
So no, it's initial handshake, so there is no early data, and the draft explicitly says that.
How many people have reviewed this draft? Read it, the latest version? Not a lot. All right, but so we've got some. It would be good to get a little bit more. Are there any people out there who have implemented or planning to implement? Okay. Well, let's see if we can get some more reviews on the list. Maybe last call will be the mechanism to do that.
I didn't look carefully. Did anybody raise their hand for implement or plan to implement?
I can't hear you.
I didn't look. I couldn't see from
I
where.
didn't see anybody who was planning to
Oh,
implement.
no, there was one over there.
One.
Yeah, I guess. I don't
That's a
think
pretty
we should.
significant one, actually.
Yeah, I don't think we should advance this until someone has implemented it. That seems like a standard even for experimental, probably.
Fair enough. And as the
This
first
is-
slide said, this is for experimental. Okay. Okay.
Hello, My name is Erik Sü. I'm from the University of Hamburg, and I'm a PhD student there. And I'm doing research in the topic of TLS and TLS session resumption especially. So I looked recently into the performance of TLS session resumption across SNI values. And I observed that the draft of TLS 1.3 is recommending against it, but at least it is clearly pointed out what are the security issues, and it is also allowed within the draft to do so. And as a problem, why it is recommended against it, I think there is lacking a mechanism to announce for a server which specific SNI values are supported for session resumption. So I looked onto, or to assess the real world performance impact of this, I scanned the Alexa Top 1K site, and I observed that, for example, the average site is building TLS connections to more than 20 different host names. And these 20 different host names, they form about 9.5 TLS trust groups. TLS trust groups in this sense, I define them if X509 certificate is valid for these host names, or if it is practical to do TLS session resumptions across these host names. And also another metric which I want to introduce is that when you retrieve a website, you find that you have multiple TLS connections which you establish sequentially, and on average these are 4 sequential TLS handshakes for the Alexa Top 1K sites. So a quick look on the performance gains when you do TLS session resumption. So in terms of the elapsed time, we find that each session resumption saves at least 20 milliseconds, or about 20 milliseconds. And another important point might be the CPU time, as it is an indicator for the consumed electricity, or the, and there we find that session resumption only uses a third of the CPU time which full handshake requires. So here I summarize the performance benefits. Doing TLS session resumption across different SNI values allows us to convert approximately 60% of the required full TLS handshakes to resumed connection establishments. This saves in terms of CPU time 44%, and it can save up to 30.6% with respect to the elapsed time for the retrieval of the website to build those connections. So then I thought about how should one implement, or how should one design such a TLS extension. And I came to the conclusion that a simple flag is sufficient. So we need a 1-bit value. And after that flag declares the subject alternative name list of the certificate as a trust group. And we define that within this trust group, each member should support session resumption with each other member of the same trust group. So there's a drawback, which are privacy considerations. So this mechanism, when you visit first the one host name and then the other, you can be, or your visits can be linked if those both host names collaborate with each other. However, I come to the conclusion that this is not a new problem, as user visits can also be linked across different host names via redirects if they use a unique identifier, or hyperlinks if they contain a unique handler. And also the feature of connection reuse of HTTP2 provides the same privacy feature, or the same privacy concern. So if we want to defend against this tracking mechanism, we should enforce shorter expiration times, yeah, for session resumption. So thank you. And are there any questions, comments?
Thanks for presenting this. It's good to see that presumption actually works. Otherwise, it would be silly. So I think, this is an idea that's been floating around for a while. Victor Vasiliev floated it a while back. So I think it's worth considering. I had a technical question about the design in your specification, which is that it was a little unclear for me in the document whether you thought the extension went in EE or in Cert. It goes in EE, right? The server's extension, where does it go? In the EE pin?
Yeah.
Okay, so the document says certificates in a couple places, so you'll want to fix that.
Okay.
From a privacy perspective, I think you're right. There's been a lot of back and forth about domains that share the same SAN in HTTP and about connection coalescence. So I think you'll want to be clear on what the DNS status is. So one thing you might say is I could resume and I wouldn't have to do a new DNS request. So you probably have to come down on that one way or the other. This is a topic, as I say, which came with the HTTP as well. The second thing is, perhaps third thing, is can you walk through the reasoning for why you think that only one bit is needed, as opposed to a way to indicate I'd accept for some of these domains but not others?
I shall explain why one bit is sufficient.
Yes, please.
And the alternative, I think, would be that we provide an entire list for which names session resumption should be supported. And I think that there are security considerations, or it's more difficult to implement this approach. And like one bit, and then we directly take the SAN values and use them for session resumption. I think it has security benefits, as nobody is going to mix up the groups or some lists which are provided. Yeah.
Okay. Well, I think I'd like to hear from server operators what they think about this. Yeah. The last thing I was going to say is we seem to be starting to accumulate one-bit flags, and it might be worth, and that's not, people don't typically worry too much about the size of the TLS handshake, but sometimes they do, and I'm wondering if it might be worthwhile defining a generic extension that was a flags extension rather than defining a pile of, because each extension basically burns 4 octets minimum, so I think maybe it's probably trying to define a flags extension. Anyway, but
an alternative design could also implement it into the certificate itself. Sure. So we can also consider that approach.
Sure, fair enough. So I should have said this at the beginning. I think this is good. I think we should pursue it.
Yeah.
Hi, Yovnir. So one of the reasons that we don't generally recommend resuming across SNIs is that often you'll get a wildcard certificate like star.example.com, and then this is valid for all of the example.com servers, but only some of them are actually co-located on the same server. So that kind of argues against the one-bit solution, because the server knows what other domains it is responsible for.
But why does the server address matter?
Sorry?
Why does the server address matter, or why it's important whether it's located on that server or not? Because you can use a session ticket encryption key also on another server, and you are fine.
Well, I might be fine, but if it's a different server, then the security properties are different. It's usually not. It's really not a good idea to just do session resumption to random servers within an organization just because they went to the economic and operational expediency of getting just one certificate for the entire organization.
And this approach is a little bit offloading some complexity to the X509 certificate. So you have to define there the right trust group, which is matching this use case.
Right, but then you have to get your certificates according to that
Yeah.
trust group. Yeah, which is, again, a bit difficult.
It's a bit difficult, but
Okay,
otherwise
we're going to close the line.
Sure, there's a difficulty somewhere and you're going to have to face it at some point, either in the PKI or in the server configuration. Yeah.
Yeah, thanks.
Yeah, please make it quick.
Victor Vasiliev, Google. This is something like I proposed 2 years ago, but for core TLS-1 spec, and then we decided we'll talk about that later. And I think now is a good time to talk. Overall, I think this is a very good idea. Specifically, there are cases like YouTube where you have a CDN with star.googlevideo.com, and you would really want to resume between those domains, but you can't because they all have different host names which you have to connect to. And because of that, I have two issues, one small and one serious. The small one is I would use new session ticket extension for this because this is an extension which changes behavior of a ticket and not the handshake itself. And the second one is, so currently the draft proposes to limit resumption to 10 minutes, which is a solution to issue which you correctly pointed out exists. However, as you've also pointed out, this is an issue which is orthogonal to privacy issues of resuming across domains, as in for re-identifying user, it would be often enough to resume to the same domain, which is like embedded via an iframe. So it is correct that we should probably take on the closer look at privacy implications of resuming across, say, a week or whatever.
I actually did that. There's another paper from me on tracking via session resumption.
Yeah, what I'm trying to say is that I'm not certain 10 minutes would work if it would like.
Yes, certainly it's. We can argue which value is the right one, and there are trade-offs at hand.
So the reason what I'm saying is that I don't think the question is of whether 10 minutes is the right one. It's a question for this draft. You see what I'm saying?
Okay, you question whether we should at all recommend some time limits.
Yeah, I think we might want to recommend, but in different draft.
Okay.
Other than that, I support adoption of this, and I am willing to implement this.
Okay, I'd just like to echo what Yov was saying. This is Nick Sullivan in Cloudflare. Is that some servers may have a certificate that is over-provisioned in terms of how many host names it covers. So it may not be able to answer every subdomain of it. There is the provision at the HTTP2 layer of what's called an origin, where if you define what the origin is, then perhaps that might be a way to define which, if a site has listed a set of origins, then that is likely a set of safe SNIs to resume. But without that additional signal, you may end up in a situation where you connect to a server on a subdomain that server just doesn't have the ability to answer for.
Yeah, we offload some complexity to the certificate itself.
Right. You're saying that the certificate has to be a lot more specific than it currently is. That there has to be a one-to-one mapping between handling everything on the certificate to handling to web servers, which I think is an unreasonable expectation.
Okay.
Okay. Thanks. How many folks have read this draft? Okay, a few. And is there anybody who is seriously opposed to this work? No.
I think Victor raised some good points about the actual design of the spec. So I think probably we should see maybe a converged draft before we actually accept it.
Yeah.
Hello, everyone. So this is just an update on the external PSK importer draft that we talked about last time. We had some input from David Benjamin, so added him as an author to the list. Thank you, or to the draft. Thank you very much for the input and contributions. Just to reiterate the problem statement here, in the 1.3 draft or spec, it says that PSKs must only be used with one particular hash function, whereas in TLS 1.2 we have no such restriction on any PSK. So the ultimate goal that we want to achieve here is to avoid hash reuse for the same PSK in different contexts, that is across different protocols. And so one of the ideas that came up was to just have an import sort of like functionality that differentiates an external PSK that is universally bound to some hash function for a particular protocol version, and then the set of cipher or set of hash algorithms that you support without changing the key schedule, such that you don't have this, misuse or reuse of a PSK across hash algorithms. So to be more concrete about that, basically assume you have some universal PSK or external PSK that has an associated hash function with it when it was actually vended. Has some associated identity as well that you would use if you were going to use it in TLS 1.2. The import functionality that we're specifying is basically a way to construct a different identity for the PSK that you would advertise on the wire. That's the composition of the external identity associated with the PSK, a label, a generic label right now, which is we specify as a protocol specific string, so TLS 1.2 or TLS 1.3, whatever version of the handshake is currently in use. So for Quick, it would be TLS 1.3 as well as the hash algorithm that you want to use this particular PSK for. So if you support SHA-256 and SHA-384, you would have one PSK being split into two with two different identities advertised on the wire. And a question that was raised in the bump version of the draft was whether or not you want to have the hash algorithm as currently specified in the identity at all. You might imagine future versions of TLS not even using this particular type, so it might make sense to fold that into the label as a way of future proofing, but this is more of just an encoding question, so we could probably sort that out later. Just as an example of how the diversification works, as I said, you have an external PSK with an associated hash. You basically HKDF it based on the imported identity with the protocol string and the hash algorithm as such, and you get, in this case, 3 particular PSKs that would be advertised on the wire. There was a question raised last time as to what is the exact overhead of this particular technique. So for example, for low power embedded devices in which you're using PSKs, external PSKs, you don't want to add more bytes to either any message of the handshake. But if you're just supporting, if you control both ends and you only want to support one particular hash algorithm, the overhead's actually quite small. It's just the size of the label and the number of bytes needed to encode the hash algorithm. Another benefit of this particular approach is that there's no change to the key schedule, which is in contrast to the universal PSK design that was originally proposed by David, which has been sort of folded in here. And we sort of cleared up the language a little bit such that it works with TLS 1.2 and prior versions, as well as 1.3 and 1.3 in the context of Quick, and potentially go forward with 1.4, dare I say it, and other versions of TLS if they should exist. Of course, a con then is this particular approach with this design. It means that if we were to rev the version or increase or add a new hash function or hash algorithm, the number of PSKs advertised on the wire would increase based on that particular new value. So that's not the best, particularly because it could get out of control quite quickly. But assuming that in a scenario in which you have external PSKs and you have a key management system to distribute these out of band, that you know what algorithms and functions and protocol versions the other side supports, so you wouldn't run into this particular problem of generically just advertising everything and finding one that sticks. So that's the rationale that we're using here. Concretely, with the draft changes since 00, we added some text to clarify the language around that a single hash function must only ever be used for a PSK, just to make that absolutely clear. Made it clear that whenever you're deriving a PSK, you would only derive one for each supported hash algorithm. So for example, if you had two Cypher suites that shared the same hash algorithm, you would not derive two PSKs for whatever reason. So in the case example, if you have ASGCM with 256 and SHA-256 with SHA-256, you'd only derive one PSK. Whereas if you had different hash algorithms and different Cypher suites, you would use more, clearly. And we made concrete how we would actually support this with TLS 1.2 and backwards versions as well. There was also another issue that was raised with respect to privacy of external PSK identifiers, in particular in the context of, I think it was DNS service-based service discovery. Thank you, Christian. I assume you're here somewhere. Yeah, so I left a note in the draft basically describing the sketch that's in the DNSSD document with the, using the time-based nonce rotation. It's not like something you can implement as written, but just sort of a note that says, using external PSKs with sticky identifiers is possibly a privacy problem. There are possible things you could do to get around that, such as the mechanism that's described in the DNSSD draft. And very likely we might just sort of point to that particular draft, assuming it goes forward, and say, perhaps just do this particular thing. There was some interest in this last time. This is a problem for TLS 1.3, especially if you want to use external PSKs. I'm sort of proposing into the group that we sort of move this document forward. So I'd like to just get a sense of the room as to what people think. But first, I think Christian has a question.
Yeah, no, it's not a question, it's just a notification that we missed the deadline, but Daniel Kaiser and I are extracting that part of the DNSSD draft and making it standalone, and we'll submit it in in the TLS group.
Excellent, thank you. Then I will just cite that to make it easier. Yes.
Yeah, John Mattsson, Ericsson. Yeah, 3GPP mandated TLS 1.3 already last release. I actually thought about this problem just a couple of weeks ago, trying to figure out what 3GPP has some PSK use cases, most are certificate, but what should we do exactly this to confirm with TLS 1.3 and PSK? So I would very much like guidance, something like this, guidance from the TLS working group on how to do this. One question, one of the motivations here is in the introduction is that this was not done in the TLS 1.3 draft because it used the same PSK with different hash function because it's hard to analyze. Does this make it easier to analyze? Now, if I have used the default SHA-256 hash function, I could use SHA-256 to derive a key for using in SHA-384. Do you have motivation why that is more secure than using the same key with different hash functions?
Do you want to answer that?
Yeah, I'm assuming John was going to follow up on that, but perhaps not.
Well, my question is sort of actually sort of related in the same answer. Yeah. The question is whether the PSK identity constitutes a channel binding, because if you can show that it constitutes a channel binding in a formal sense, then yeah, you just get to skip like all of these like multiple hash functions problems because you can prove that they're sort of independent and indistinguishable. But the design of in the draft doesn't specifically say that it is attempting to be a channel binding, even though it looks like it should be. I'm not sure if it is, but
I'm not understanding why is a channel binding relevant in this case?
Yeah.
So a channel bind, what you're effectively doing is you're binding the PSK of the previous session to the new key of the new session, of the resume session.
No, this isn't about resumption. This is about external PSKs.
The external PSK is established somehow through some protocol, even if that's out of bound. No?
I mean, I guess, but I mean, you're sure.
If the external PSK is established through some mechanism, then the problem you can avoid thinking about the hashes if it just counts as a channel binding, and thus you just know that the hash of the previous session can't be confused with a different hash.
Well, no, but I mean, so the way the PSK was established was like I called Chris on the phone and I read the numbers to him.
But how do you know that, like, I just have this key. How does the new session know that it was established by phone call or established by TLS-12?
It doesn't. It doesn't.
Then you have to worry about how the hashes interact.
Right. So the rationale, I mean, we can certainly attempt to get some analysis of this, though I think we had some informal analysis from Karthik, but the rationale here is that the hash function in the, can you go back to the thing that shows generation? The purpose, no, the next slide. The purpose of this hash function here, right, is just to provide, is basically to act as a PRF with respect to the output keys. And so that's totally decoupled from the hash function you use later. So that's why it's safe to use the same hash for multiple output algorithms, multiple target algorithms.
I mean, I agree, but I think it's because this appears to constitute what would be a channel binding. As in, if the previous hash was SHA-256, then you've established that by including it in the HKDF.
But no, I don't think so, but probably should take this offline.
Yeah, offline.
Okay.
That is to say, we will certainly seek formal analysis to make sure this is okay going forward. But yeah.
Okay, how many folks have read this draft? Okay, significant number. Anybody opposed to adopting this draft as a working group item? Okay, we'll take that to the list. Thanks, Chris. What's next?
All right, hello. I'm Tommy Pauly from Apple, and I'll be presenting these actually two drafts that we submitted regarding how to do NAT detection within secure transport protocols. Essentially, that's just within TLS and QUIC right now. So we have two drafts that we submitted in tandem, which are essentially the same mechanism within the two different protocols. So what I want to do here is just cover our use case motivations and to talk about some of the trade-offs in the design. There's definitely some things that need to be done on the wire format encoding. We've had a lot of discussion on the list already. Thank you for the people who did read that and give that feedback. We will take that into account, but I think we'll punt the rest of that discussion to the next rev. So there are 4 different use cases for why we would do this in the first place. So I just want to walk through those now. So one issue that we have with long-lived connections, of course, is that you can have NAT rebindings or stateful firewall rebindings that can happen. And oftentimes it's not easy to detect those, or you don't know if one is about to happen. Oftentimes with long-lived connections, we'll have a fair number of keep alives that we do, or try to detect what the rebinding timeouts are. So the goal here is that if we can detect that there is a NAT, we can seed what our keep alive timeouts are going to be earlier on. Of course, not detecting that there is a NAT doesn't remove the need for keep alives. There could be a stateful firewall involved, but essentially if we do positively identify that we are behind a NAT, we may want to bias some of the heuristics we do for long-lived connections. And this definitely will look different for protocols like QUIC, which can survive NAT rebindings, but it may let us know that these may be happening. The other use case that we thought of here is that if we detect that we are not behind a NAT, we are much more likely to believe that our client IP address is effectively a public address and we are using it as a unique identifier. This plays into any privacy considerations that we have for other protocols. So the example that led us to start working on this was that if I'm behind a NAT and I'm using DNS over TLS or some other mechanism in which I'm trying to obscure my DNS traffic, I may want to open up multiple different TLS connections to make them look more obscured or more unrelated to the actual dot server. However, if I'm not actually behind a NAT and I have a public IP address, that's just going to be directly obvious to the server, and it's going to see a whole bunch of queries coming from the same client, and it's going to be a lot more linkable and related than it would be otherwise. Oh, did we have a? Yeah. So net rebinding detection I already discussed, and the other item that we have is if we can detect what our public IP address actually is, if we are behind a NAT, we can do better metrics collections on knowing what ASN we are, and so we can do better correlation of what performance issues or other functionality issues that we're seeing when we are trying to debug things in the wild from the client perspective. This is an interesting privacy question here to some degree. Is it a privacy issue for the client to know their own public IP address? They are knowing a little bit more about where they are in the environment they're in. I think there can be some discussion about that. I would argue that it's not really a terrible thing because everyone upstream in the servers already know where you are. It's actually just something that's hidden from the client themselves. So the goals we had with this were to allow the endpoints to detect the presence of an address transforming middle box, generally a NAT, and also to allow you to discover your own public IP address, and this allows you to do like the ASN detection, stuff like that. And doing this essentially passively without doing just probe connections, do this within existing connections that we're doing to the web. The constraints, of course, is that we only want to send this type of information that's in an encrypted way. Protocols like IKE already do NAT detection, but they have to do hashing on that because that would otherwise be visible to everyone that they're sending it to. This is another way to do a NAT detection effectively, but it gets you less information on the client side. Another goal is, or another constraint essentially, is that we only want to ever be sending the publicly perceived addresses. The client should never send their own internal private address because that's definitely a privacy leak. And then the other constraint is that we cannot rely on the validity of the information. The other side can certainly lie to you at any point. You should not be making security decisions based on the address you are told. That would be a terrible thing. This is mainly just like a hint to improve heuristics and metrics. So the specific protocols that are being proposed are in TLS to have a client address extension in which asymmetrically the client requests what is my public address and the server sends that to them. Pretty simple. In Quick, we were talking about doing a symmetric request in which you can essentially, either peer can request what is my publicly perceived IP address, and then that gets sent by the peer to it. So here's just a simple little diagram. Client connects to the server, says, I support network address. I am requesting my public network address. It gets sent back to them over TLS. Pretty simple. The limitations here are that it can't detect stateful firewalls that aren't translating addresses. This also is only benefiting the client. It's unclear if the server really wants to be able to support this. It may be a little bit more complex, but if we have use cases, that could certainly be added. Another interesting point is that because, at least the way it's currently defined in the draft, it only is happening during the handshake, it doesn't take into account protocols like MPTCP in which you are going to be rebinding to different addresses. That would lead to saying maybe we should have something that we can do later on in the connection, which is exactly what we are proposing that we can do for Quick. Pretty simple. We just say, hey, what's my public address? And then you get a response back. So the limitations here are that still you can't detect stateful firewalls that don't translate your addresses, but you can handle multipath migration rebindings. And this can actually be a really useful way of adding ways to help connection migration realize when a migration has happened because of a NAT rebinding versus an explicit decision to switch different networks. And so that's essentially it. We'd love to hear any feedback or thoughts of if this is useful. I know there were some similar ideas of using this as a HTTP2 thing rather than TLS. And if people think that's a better way to pursue this, let us know.
Wes Hardiker, USCISI. Couple of questions, really quick. Is this NAT v4 specific? You didn't really state whether you were considering v6 or not.
So, I mean,
We're cutting the
hopefully
line
people
at
aren't
this
doing.
point.
Yeah, great. Hopefully people aren't doing NAT66 all that much, but it definitely applies everywhere. I think the wire formats do any address family encoding because you could have a NAT64, you could have a NAT66, and so you do want to detect that either way.
Okay. The bigger question is, why is this a TLS specific problem? If clients around the internet need to know their public's address, which I think might actually be somewhat needed by games and lots of stuff, why are we doing this in each protocol as opposed to doing some more generic solution that operates at a different level?
So I think in the case of Quick, it's a little clearer because I believe to some degree this is kind of a transport handshake question. That's nice because we already have an encrypted transport there because it's all kind of baked in. Putting this in like TCP would not be something that we could easily extend, and also we want to make sure the information is encrypted. The other direction you go is that you put it inside protocols that run on top of TLS, and you just redefine it for each of those use cases. So I agree that it's not totally clean. I think the Quick story is much cleaner.
Hi, Daniel Kahn-Gilmore, ACLU. So thanks for bringing this work here. I do think this looks useful. I'm a little bit curious about when I appreciate that you're aware of the problem with a server lying, and that you said you obviously wouldn't make any sort of security decisions on this basis. And yet, so you see this address change only for TLS only during the handshake, right? So it seems like there's some sort of cross TLS session thing potentially that would be going on where you might observe a rebinding with one TLS session that your address has changed that might be different from another. Sorry. What would you do with this information as a client that isn't security sensitive?
So in the case, so TLS, unless it's over something like MPTCP, wouldn't really be detecting rebindings because generally your connection is going to die after rebinding. So essentially, if I'm just detecting that I am behind a NAT, what is going to influence are my decisions about like keep alive timeouts. I think also when we're talking about lying, I think it's much easier if you are lying to assume that you're going to get a mismatch of your addresses. Someone randomly guessing what your public IP address really is that you think it is probably a lot harder to do. So it may be easier to detect and trust that you're not actually behind a NAT.
So you're saying that you use it specifically just to detect that you're behind a NAT and not try to do anything with the address, right? I mean, the other example was
you shouldn't do anything. The only thing you could detect and trust is that you're not behind a NAT, or that somehow your public IP address really is visible. So essentially says this information is leaked.
Okay.
We're out of time for this particular topic. I think we ought to continue the discussion on the list.
Yeah.
And move to the next. Sorry, folks.
Thank you.
Hello, everyone. My name is Haiguang from Huawei. Today I'm going to introduce our draft using identity as a raw public key or TLS. This slide explains our motivation actually. with the TLS 1.3 support using raw public key in the handshake protocols, it has two advantages. First is simple in the authentication. No certificate chains involved in the verification natures. The second is lightweight in the communication. Actually, certificate normally takes about 1 KB, and a raw public key maybe just a few tens of bytes. So it's quite lightweight in communication and also in the storage. So, however, issues with using the raw public keys, I need to maintain a binding list for the public key and the identity. You mentioned we have a huge network with millions of a few hundred millions of devices. So to maintain such a huge binding list is not easy task. So to solve this issue, we propose to use identity-based cryptography. In fact, it's identity-based signature to examine the server from maintain such a huge binding list between public keys and identity. So I have two usage scenarios for this TLS-IBC. Actually, the first is we can use it for the telecom operators. Currently, telecom operators, they use SIM card for the authentication. That is, the device and the server, they have maintained symmetric keys in the SIM card and the home server to do the mutual authentication. However, this requires the server to maintain a huge database. One possible solution is we use the IETF then we can reduce the list to manifolds, maybe just a few records, and plus a relocation list. Actually, in the 5G networks, IETF already been supported, and currently it's supported with the certificate. The second usage scenario is actually we can use the TLS-IBC over the internet for the IoT services. So, for example, the server can authenticate the clients with identity-based signatures. So I would like to emphasize that both use cases we will be use the IBC for the IoT networks, not for the browser and server communication scenarios. So in this table, I list various identity-based protocols, including standards from ISO, IETF, and IEEE. Some of them are for the crypto algorithm itself, some are for the supporting protocols. So you can, if you are interested, you can go into the details of these protocols. To use the identity as a raw public key, we might need to extend the TLS 1.3 to support IBC. First is need to support identity as a raw public key. Second, we need to support IBS signature algorithm in place of a raw public key signature algorithm used. So currently, our drafts support 4 IBS algorithm. First is ECCSI. It is specified in RFC 6507. It is elliptical-based IBS algorithm. The second to the fourth one are from ISO. It's IBS 1, IBS 2, and Chinese IBS. They are bilinear pairing-based IBS algorithm. To support IBS or TLS, we need to extend the signature scheme data structure by supporting each signature algorithm with code points. So here we list the 4 possible code points that can be reserved for it. This is shows the data structure we extend to support the IBS. We reuse the data structure used by the raw public key to carry the public key and algorithm identifiers. For example, the original subject public key field, we filled with the identity, and for the algorithm field, the OID of IBS algorithm is put there. A new data structure is defined to carry the PKG parameters. With IBS algorithm, there's a centralized PKG that generates priority keys for the devices. So they might need to exchange the parameters with the server. In case the single level IBS user scenarios, maybe this can be omitted from the handshake. And also we need define a new data structure to carry the signature values, including points on the elliptic curve and PVT. For
we're running towards the end, so you might want to.
Okay, maybe just yeah.
Jump to the
so
end.
This is the handshake protocols. We just put some ECCSI and also how they exchange the the public key information and IBS over the handshake protocols. We also have some work in the ITUT SG17, and they cover some more aspects of the IBS algorithm, including the, for example, the security requirement and IBC algorithm and the key management and also authentication protocols. Last slide. So the way forward is we will ask the group here to reserve following code points for us to use in the implementation testing, mainly the full codes for the signature algorithm. Yeah, that's all.
So to be clear, he's not asking for working group adoption. This is kind of a, hey, what's going on? So I believe the way forward here is that the code point registry is clear that it's specification required. So, and anything we'll do, including an internet draft. So I believe the way forward here is this draft is going to be forwarded to the designated expert list, and they will take it and see what happens and go from there. That's basically the idea. Is there's anyone here that's screaming for working group adoption of this? Please get to the microphone. Okay. So I'll get with you to make sure we understand exactly what's going to happen, where you're going to send the email, excuse me, to get the draft to the designated experts to make sure that we get the code point thing going, and we'll go from there, and we'll see you all tomorrow. Thank you very much.
Okay, thank you very much.
Yeah, where's the other blue sheet?
Can someone bring up the blue sheets?
Sorry, the blue sheets haven't been up the center yet. Blue sheets haven't covered this.
All right, there's a blue. Who's got the blue sheet? Okay, pass it up to. Go. Is there another blue sheet? We got lots of blue sheets. So we got an extra. We're so popular.